In this video, we are going to see some sample practice questions for practicing quantitative reasoning in GRE test. What is the sum of all integers x such that negative 37 is less than x, less than or equal to 35? Since negative 37 is less than x can take all possible values between negative 36 to 35, inclusive of negative 36 and negative 35. So we can split this into groups, say negative 36 to negative 1 and then 0 to 35. When I sum it up, it looks like the values negative 35, positive 35, negative 34, etc. All these values cancels out and I'm left with just 0 and negative 36. So when I add them up, I get that as negative 36 and hence my answer is C. The current ratio of boys to girls at a certain school is 2 to 5. So let it be B by G equal to 2 on 5. If 12 additional boys were added to the school, so if B becomes B plus 12, and the ratio between B plus 12 by G is 4/9. I can split this B plus 12 by G as B by G plus 12 by G, which is 4/9. When I want to solve for 12 by G, since I already got the value for B by G as 2/5, plugging in that value, 12 by G is 2 on 45, or I can get the value for G as 270. But the question here is, how many boys currently attend the school? So B by G is 2 by 5. Since G is 270, I can solve for B and I get B as 108. So my answer to this question is E. We have got two different columns. One is 9A plus 3B, the other one is 6C plus 3D, where these A, B, C, D are positive integers, satisfying the result A by 2 plus B by 6 equals C by 3 plus D by 9. We have to find out which column is greater or lesser, or to check whether these two columns are equal. Now if I'm taking some test values, say A equal to 2, C equal to 3, B equal to 6 and D equal to 9, plugging in this equation, I get that the right hand side as well as the left hand side is satisfied. So let us take these four values. Now when I find the value for 9A plus 3B, that becomes 36, whereas the value under column B, which is 6C plus 3D, is 45. So I know that column B is greater. So here in this case, K value is given as a series, sum of a series 1 plus half plus 1/4 plus 1/8, etc. up to 1 on 128. We have got two different values, K and 2. We have to check whether K and 2 are equal, or K is greater than 2, or K is less than 2. Now since K value is given, we can sum it up. by taking the LCM as 128. So the whole value of k becomes 1.992. So since 1.992, I know that 2 is bigger, or k is less than 2. For the fourth question, the same way, if n value is given as a sum of series 1 plus 1 by 2 plus 1/3 etc. 1 by 7, we have to check whether n and 3 are equal, greater or lesser. So if I add them up by taking the LCM for 2, 3, 4, 5, 6, 7 as 140, I get the total as 2.593. If 7 workers can build 7 cars in 7 days, 7 workers can build 7 cars in 7 days. So number will be the rate times the time times the number of workers. So here, if I use that 7 cars, number of cars is 7, is the rate at which it is built multiplied by the time, which is 7 days, and number of workers is also 7. So from this I can calculate the value for R, which is 1/7. How many days would it take 5 workers to build 5 cars? So 5 workers and 5 cars. So for the same equation, if I plug in the number of cars as 5, and since I already got the value for the rate as 1/7, and since it says 5 workers, I can find the number of days t here. Solving for t, I get t equal to 7. So my answer is C. If 6 workers can build 4 cars in 2 days, how many days would it take 8 workers to build 6 cars? The same case, the number of cars will be the rate times that number of days times the number of workers. 4 cars, rate R is unknown to us. The time is 2 days and 6 workers. So for this, the value for R is 1/3. From the second equation, second given result, 8 workers to build 6 cars. So 6 cars will be, R is already known, 1/3, t times 8. So now you can solve for t and you get t equal to 9 divided by 4. So they can build only 9/4 of a car. We can paint a house 3 times faster than Alice can paint a house. So it looks like B is 3 times A. If working together, it takes Alice and B 24 hours to paint a house. So A plus B will be 1 by 24 of the house. The work will be completed. Now, we are interested in finding the value for A and B. Since I know B is equal to 3 times A, in this equation if I plug in A plus 3A is 1 by 24, from which I can solve for A is 1 by 96. So if A works all alone, Alice works all alone, she can complete the work what she can complete in 1 day is 1 by 96 of the work. So it will take 96 days for her to finish the work, and your answer is Margie has n candies where n is lying between 20 to 50. If it is divided equally to 5 children, 1 candy is left, and if it is divided equally to 6 children, 2 candies are left. Maybe my first choice is if n is equal to 7, 2 remaining when it is divided equally to 5 children by giving 1, 1, 1 to each. If there are 6 children, then I can divide that equally to 6 children with 1 remaining for 7. it will be 0 remaining. Or I may have another choice when n is 37 also. It leaves 2 remainder when it is equally divided to 5. 7, 7, 7 5s are 35, remainder is 2. For 6 children, 6, 6 each, 1 remaining. And for 7 children,